Hello everyone, welcome back to Let's Unbound. Today I'll be discussing 5 marker questions which came for Math Kangaroo 2024 exam for level 7 and 8. So let's just start with the first question. So this is question 21. The digits 0 to 9 can be drawn with horizontal and vertical segments as shown below. Greg chooses 3 different digits. In total, his digits have 5 horizontal segments and 10 vertical segments. What is the sum of his 3 digits? Now let's just understand the question first. So there are digits from 0 to 9, okay, and that you can see digitally written down below. But Greg will choose only 3 different digits. So we need to understand there are 3 digits which Greg will choose and different digits. So none of them can be same. So this is important. And in total, his digits have 5 horizontal segments and 10 vertical segments. Now, what do we mean by horizontal and vertical segments? So let's just have a look. If you look at this digit 0, you can see that 0 has horizontal segments, which are these two. Can you see? So there are 2 horizontal segments used in digit 0. And how many vertical? So you can see there are 4 vertical segments used for 0. So in total, horizontal segments are 2 and vertical segments are 4 for digit 0. Similarly, for digit 1 to 9 also, I've written it here for your convenience. So you can see for all the digits, we have the vertical and horizontal segments ready. Now, can you notice one thing? The maximum of horizontal segments for all the digits from 0 to 9 is 3. More than 3 we can't see in any of the digits. And the maximum segments for vertical, you can see it's 4. So let's just write down that as well. Okay. Now, coming to the question, Greg wants to choose 3 different digits, right? So Greg wants to choose 3 different digits. So I've placed 3 boxes here, each for 1 digit. But there is a condition that his digits have 5 horizontal segments and 10 vertical segments in total. Don't forget this word, in total. That means the number of segments you'll be using in the first digit and the second digit and the third digit. So when you add all the horizontal segments for all the 3 digits, that should be in total 5. And similarly, the total vertical segment should be 10. Okay, so this is the condition for the 3 digits which are selected by Greg. Now our task is to choose that out of these 10 digits from 0 to 9, which 3 digits Greg will choose so that the condition of the segments is also satisfied, and also the sum of these 3 digits based on the segments should be true. Okay, so let's just start with the combinations which are possible. So I am focusing on the horizontal segments which are 5. Now I need to create in such a way so that when I add them, I should get 5. But I don't have to forget that maximum of horizontal segments could be 3. So the segments could be either 0, 1, 2, and max it will go up till 3. So these are the possibilities for segments, right? So let's see the possibilities. Can you look here? We can take a digit which has 0 horizontal segments, then the second digit can come here with 2 horizontal segments, and the third digit could have 3 horizontal segments. Similarly, there are other possibilities also, and in all the 3 cases, I have not exceeded more than 3, but keeping in mind that the sum should make 5, so 0 plus 2 plus 3 gives you 5. Similarly, 1 plus 1 plus 3 gives you 5. And the last 1 plus 2 also gives you 5. But out of these all, there is only one correct possibility. Okay, and why is it so? Because we also have to take care about the second condition, that is the vertical segment should be 10. So the digits which you have considered, keeping in mind the horizontal segments, are they also satisfying the sum of vertical segments to be 10? So we need to check that. Let's start with the last one first. Let's check this. So we have horizontal segment as 1. So let's just check from the list of digits we have from here that which digit has horizontal segment 1. So you can see, I can see horizontal segment 1 here and horizontal segment 1 here. Yeah, these two. So 4 and 7, right? So we can pick any one. So let's say 4 or 7. That could be used for the, okay, so for the first one, it's a 4 or 7. So let me just write it here. These are the three cases. Let me take A, B, C. So I'm checking for the C part. So the first one could be 4 or 7. The second digit could be, okay, second digit could be H2. So H2, you can see I have digit 0 with H2. Anybody else? No. So only 0 is the possibility for the digit. And the third one is H2 again. So H2, there is only one possibility, that is 0. So that means the third digit and the second digit, they are same. But that's not possible. Why? We read the question again. You remember I made you highlight that Greg is choosing three different digits. So they cannot have the same digit at two different places. So that means my third possibility is discarded already. Let's just check now the second possibility, that is B. So we have the first digit with H1. Okay, so what is H1? Let's just check. H1 means we have again two possibilities, 4 or 7. Second possibility is again H1. So 4 or 7. So if I'm taking 4 in the first, I can take second digit as 7 so that I don't repeat also, and I'm maintaining the condition. The third is H3. So with H3, I see a lot of digits. We have H3, 9, 8, 6, 5, 3, and 2. There are so many. Okay, so that means it's difficult to choose from these digits, right? Okay, so we need to definitely look for the second condition, that is my total count for vertical segment should be 10. If I have taken 4 as my first digit, so in 4, you see how many vertical segments are covered? 3. Okay. For 7, how many vertical segments are covered? 2. So 5 are already covered and total should be 10, right? So that means if 5 are already covered, so only 5 can be used further, but maximum vertical segments in any digit is 4. So even if you add 5 plus 4, you're going to get 9, which will never be total 10. That means the third digit, no matter you pick 2 or you pick 3 or you pick 5 or 6 or 8 or 9, doesn't matter, because the total count for your vertical segment will never be 10. Okay, so that means my option B is also discarded. So very clearly we see option A is right, but we need to check why. So let me create the digits for A. I can directly write here. So when first digit, it says H0 for option for the case A, H0. So H0 means I have only one digit, that is 1 with H0. You can see here. So I can place 1 here. Then with H2, how many options I have? Oh, there is only one, that is digit 0. And with H3, I have so many options again. So for H3, I have digit 2, digit 3, digit 5, 6, 8, and 9. I need to choose which will fit best over here in my last space for the third digit. So for that, we are again going to come on our second condition, that is vertical segment should be total of 10. So 1, digit 1, how many vertical segments are already used in digit 1? 2. So 2 are used. So for vertical, 2 are used already. Then for 0, can you count? 1, 2, 3, 4. 4 are used in the second digit. Okay, so first digit, second digit. 6 are used. So that means the third digit which you're going to choose, that should have 4 vertical segments. So that total is 10. So can you think of a digit out of these where you have 4 vertical segments? 2 has 4 vertical segment? No. 3 has 4 vertical segment? No. Then 5 has? No. 6 has? No. Only 8 has 4 vertical segments, you can see here, right? So we will be using digit 8, which fits well with our H3 and vertical segment 4. If you now check all these three digits 1, 0, and 8, they are all satisfying the condition, that is H5 will be the sum when we add the horizontal segments for all three, and vertical segment sum will be 10 if I add for all the three digits, right? So now what they want us to answer from the question is the sum of his three digits. So the digits are 1, 0, and 8. So sum will be 1 plus 0 plus 8, which is 9. Okay, so that's how we get option A. I know it's a lengthy question, but I need to explain you properly, and I hope this question is quite easy now. Moving on to the next question. Question 22, which is very simple and easy based on symmetry. Question 22 says, Thomas wants to shade two additional squares on the diagram shown so that the resulting pattern has a single axis of symmetry. In how many different ways can he do this? So let's just check each axis of symmetry and see what are the possible patterns from every axis of symmetry. So with the horizontal one, so horizontal means, so don't forget you can use only two additional squares, that's it, right? So with respect to horizontal symmetry, we need to see where shall I place the two additional squares in my diagram so that it is symmetrical. So that means I should shade this and I should shade this. Okay, so that means there is only one possible way. So there is one possible way. Now let's come to the vertical. If I draw a vertical axis of symmetry, what are the possibilities of adding two additional squares? I think here and here, so that the pattern is symmetrical. So there is only one possibility for vertical axis. Moving on to the diagonal, because diagonal is also one of the axes of symmetry. So diagonals are possible from two sides, left and right. If I take the left line of symmetry, which is this, so how shall I shade the two additional squares? So one should be this, right, and another should be this, so that they are symmetrical across this line of symmetry. Okay, is there any other way across diagonal towards left? No, just one. So for vertical also we had one, for diagonal left also we have one. Coming to the diagonal right, so let me just draw from the right side. So can you see the moment I am drawing the right, the given existing square got split into two halves, right? So please don't forget to notice that. All right, anyway, so let me just draw this line to make it easy. Now, okay, so one square is here. So shall I place this square here? But we need to put one more additional square because there should be two in total. So one can be this, the other could be this one. Can you see why I've put here? Because half will come across this side and half will come here. So in total one, and obviously one was over here, right? Okay, so one is fixed here and the other I took on this side, right? So that the line can divide into two equal halves. So one square here, another here, one possibility. Same thing, one square is here, another square instead of the bottom, I can put it here. Still it will work. And similarly, I can put it on the top, the second square, and still I get symmetry. That means for the diagonal from the right side, I have three different possibilities of getting the symmetrical pattern. So that means in total, how many possibilities I have? 3 plus 1 plus 1 plus 1. That is in total 6. Okay, so which is option E. Quite simple question. So 6 is the correct answer. Let's move to the next question, which is question 23. The diagram shows three semicircles inside a rectangle. The middle semicircle touches the other two semicircles, which in turn each touch a shorter side of the rectangle. The largest semicircle also touches one of the longer sides of the rectangle. The shortest distances from that side of the rectangle to the other two semicircles are 5 centimeters and 7 centimeters respectively as shown in the diagram. What is the perimeter in centimeter of the rectangle? Okay, quite a big question. They are asking us what is the perimeter of the rectangle. But before we jump to the formula for perimeter, we need to find the length and width. Length is given to us, which is 36 centimeters, but width is missing and you can see a question mark which I've already placed. Now this width, if you see, is it not equal to the radius of the bigger circle out there, right? So width is same as your, so length is given to us as 36. Width is missing, but we can see width is same as the radius of the biggest semicircle. Let me mark it as R1. If I find this somehow, then I can easily use the formula of area of rectangle, which is length. Okay, so we need to find perimeter. So area, so the perimeter formula will be 2 times length plus width. So we have to find perimeter. If the question would have asked you to find area, then you could have used the formula for area. Okay, coming to the other radius. So let me, name the radius for all the three semicircles as R1, R2, R3. One more thing, if you notice, if this is R1, what about this? This is also R1, okay? And if this is R1, so this much segment will be 2 times R1, isn't it? This much will be 2R1. Similarly, this much will be 2R2 and this much will be 2R3 if I'm not wrong. Okay. So let's just see what is the relation between R1, R2 and R1, R3 because ultimately we need to collect the value for R1. Okay, now just see they have given us some extra information that this much portion is 5 centimeters. How can I find this? Can I say that total, if I get the total value, and if I subtract R1 minus R2, I will get this 5 centimeter. Yes. Similarly, if I subtract R1 and R3, I will get this value, that is 7 centimeters. Simple. Okay, so I get two information. R1 minus R2 is 5, and similarly R1 minus R3 is 7. Okay, what other information just now I told you that if this is R1, it's a semicircle. So obviously 2 times R1, right? And then 2 times R2, and then 2 times R3. Is it not equal to 36? Yes, total is 36. So we get another information that 2 times R1, then R2 and R3 total gives you 36. I can take 2 common and divide 36 by 2. So that will give me 18. So that means R1 plus R2 plus R3 is 18. But I need to focus on my R1. So why don't I use the two information which I collected and try to put the value of R2 and R3 in terms of R1. Okay, so what can I say about R2 from this equation? Can I say R2 is nothing but R1 minus 5? Just swap this. So R2 can be written from here. And similarly, the second equation, from here we can get the value of R3, which will be R1 plus 7. Okay, so ultimately we are going to get everything in terms of R1. So you can see that there. Okay, now simply we are going to solve all the like terms, that is R1 we can collect. It will be 3R1 negative 12 equal 18. So what will be R1? 30 over 3. So that is 10. So we got our R1 so easily, that is 10. And R1 is nothing but the width of the rectangle. Okay, so we got R1 value as 10. And now the last step, that is perimeter of rectangle. So perimeter formula is 2 times length plus width. So what was the length? 36 given to us, and 10 we just calculated. So just do the calculation and we get the perimeter, which is 92, and the option is B. I hope this was quite simple, easy. Okay, so B option is correct. Moving on to question 24. A group of 50 students are sitting in a circle, throwing a ball. Each student who gets the ball throws it to the sixth student, sitting counterclockwise from where they are sitting, who catches it. Freda catches the ball 100 times. In that time, how many students never get to catch the ball? Okay, now few important things again. How many students are there in total? There are 50 students. How they are sitting in a circle. Okay, so let's say like this. Okay, I have put few points over there. Let's assume those points are students, but those are just few students. Total will be 50. Just to show you how they might be sitting, it will be like this. Okay, so across the entire circle the students are sitting and total are 50. So obviously the count will keep on moving, and you can finish making it 50. It's not possible to add so many, so just for an idea I've given here. And how are they throwing the ball? They are throwing the ball to the sixth student. For example, if this here is the ball, so this student is going to throw to the sixth student who is sitting counterclockwise. Counterclockwise means anti-clockwise. Okay, so you can see the arrow how I have drawn. So that means the ball should be thrown in this direction. And where to throw? To the sixth student. Sixth student means where? Not to the second, third, fourth, fifth, but to the sixth student, from where the student is sitting. From that place to the sixth student we need to throw. Okay. Now Freda, one of the students out of 50, she catches the ball 100 times. Now if I tell you this 100 times is not very important right now, what important is that Freda They're asking how many students never get to catch the ball. Now, obviously, if there are 50 students and the throw is happening in a way that every student who gets the ball is throwing to the sixth student, that means in between there are many students who are being missed out, right? And after certain pattern, there will be fixed number of students who are going to get the ball, right? Now that's the thing. So first thing is Freda catches the ball 100 times. That's okay. But our focus should be that after how many throws Freda gets the ball, right? So how we are going to find that? Total students, we know it's 50, and the throw is happening to the sixth student. So to meet both these conditions, we need to find the multiple of 50 and 6. And that is very easy in maths. We can just find the LCM of 6 and 50 to get 150 throws. So you will see we have taken the LCM to get how many throws happened. Now, this is the total number of throws. But what this means, how will we get how many students received the catch? We have to remember that every throw happened to the sixth student from the actual sitting student, right? So it's at a gap of every catch is happening to the sixth student, right? So if I divide it by 6, I'm going to get those number of students who received the catch. But now question is asking how many students never received the catch. So total number of students are 50. If I subtract this 25, I'm going to get those students who never received the catch. So that is again 25. In this particular question, it came out to be equal, right? But it might differ from question to question. So it's very important what the question is asking, and that's how we need to do the calculation. So we are getting the answer 25, that is matching to option D. So option D is correct. Moving on to our last question for today, that is question 25. So question 25 says, farmer, okay, question 25. Daniel wants to complete the diagram so that each box in the middle and top rows will contain the product of the values in the two boxes below it, and each box contains a positive integer. He wants the value in the top box to be 720. How many different values can the integer n take? Now you can see 720 is in the topmost box. We need to fill these boxes, and finally we need to see that how many different values can the integer n take. Okay, and how they are explaining the question is that whatever will come in this box, so basically 720 is going to be the product of these two numbers. Okay, so let me take these two numbers as a and b. And further, A and B, A is product of these two numbers and B is product of these two numbers. So N is common between A and B, okay? So let me take those numbers as X and Y, right? So if 720 is product of A and B and A is further product of XN and NY, so can I say 720 is also combination of product x n n y, that is x n square y, right? So I have put it here in this way. 720 can be written as product of a and b, and a and b can be further written as x n and y. So 720 should be x y n square. Okay, now what is this x y n square? Is it not the factors of 720? So let's find the prime factorization for 720. So here is the prime factorization, and you can see that 2 is coming so many times, that is 4. 3 is coming 2 times, 5 is coming 1 time, and 1 is coming 1 time. So that means the prime factorization of 720 goes like this. Okay, so you can see here. Now, since 720 is equal to xyn square, So obviously I can put x, y, n square equal to the prime factorization. Now our task is, if I try to compare both the sides, I need to figure out what are the possible different values for n. Okay, so if on the left side you can see it's n square, so definitely I need to pick that value of the digits so that it should be square of something, because if n square is equal to some digit, some answer over here, n will be the root of that number, right? Got the logic? So let's just see the possible values of n, right? So first thing, if n square is 1, so I'm just trying to compare if n square is 1, right? Because xy could be, right, the rest of the things. It's possible because it's product. So we can pick any number. So we have to be wise enough to choose which will give us the correct logic. So if n square is 1, right? N square is 1. So n will be what? N will be just 1, right? Second possibility, if n square is 2 raised to 4. So can you see 2 raised to 4 is there? So if n square is this, so what will be n? It will be root of this, right? So if n square is 2 times 2 times 2 times 2, because 2 raised to 4 means what? This. So n will be what? Just 2 times 2, that will be 4. So n will be 4, 2 times 2. I'm directly writing. Next, if n square is just 2 square, I can just pick 2 square. Why? Because 2 raised to 4 can also be written like this. Okay, so I'm just picking n square as 2 raised to 2. So if n square is 2 raised to 2, so n will be just 2. So the value of n is 2. Next up we have if n square is 3 square. Can you see? N square is 3 square. So that means n will be just 3. Next up we have if n square is 2 raised to 4 and 3 raised to 2. That means n square could be this also. Now you will say why? Because x could be 5 and y could be 1, or y could be 5 and x could be 1. So n square is 2 raised to 4 and 3 raised to 2. So n will be what? What will be the root of this? Just reduce the power by 2. So it will be 2. 4 divided by 2, and from here it will be just 3, so that means it's going to be 12. So n is 12. And last one, if your n is, instead of saying this, what if I take n square only 2 raised to 2 and 3 raised to 2? So n will be just 2 from here and 3 from here, so it will give me 6. Okay, so n will be 6. And I don't see any other possibility from the given prime factorization. So I took all the possibilities. If you're getting confused, you can rewrite this prime factorization. You can break down if you're getting confused completely. You can break like this, okay? But it would have been very lengthy, so I didn't write it. Now, you can pick up as per your convenience. These two, or this and this, right? Or just 5 or 1 or 3, that you have to select which will be the correct way. Okay, not every number will work correctly for n square, so you have to be very particular which combinations you're picking. So these are the possible values of n. So let's count how many: 1, 2, 3, 4, 5 and 6. So total are 6 possibilities of n. So option D is correct. Right, so this was all for today's class. I will see you in the next video with the solutions of question number 26 to 30 for grade 7-8 for Math Kangaroo 2024.